Okay, so the diagram shows two identical parallelograms on the coordinates of the four vertices. Okay, so the vertices mean the corner points. So that's marked there A, B and C. So we've got to determine what A, B and C are, essentially. Okay. Now let's first of all look at what A is here. Okay. Now we just need to appreciate that A has things in common with other coordinates. So for instance, the coordinate of this vertex here, it has something in common with it, because if you think about it, to get to that coordinate you need to go across first and then up. So you're going across 11, up 7. Well, in the case of A, you're going to follow a similar journey to start with. You're going to go across the same amount, aren't you? So just as you're going across 11 and then you're going up to this coordinate, you're doing the same for A. You're going across 11, except then you're going down. So we can write 11 here because we're going across 11 first. The question is then, how much do we go down? Well, we can compare it to this coordinate here, because if we look here, it's gone down to -1. Okay, so that's what A will be there, just by using these two coordinates. We can do something similar then to find out B and C. So for example, for B, right, you just need to appreciate that the Y coordinate is going to be the same as that there, 9, yeah, because of course to get to that coordinate you've got to go across 13, but you're going up 9. Well, obviously we're going across a lot more here. Okay, I don't know how much we're going across yet, but we're going up. Okay, the same, we're going up 9 as we're going there. So we can write 9 here. Question is then, what value will go here? How many we're going across? Okay, and in terms of how many we're going across, we need to get from origin to here. Look at this coordinate here, the one before it. It's 19, yeah? So you're going across here 19 to start with, and then we need to go a little bit more. So how much more? Well, if you look at these two coordinates, you can see we've got 11 here and then 13. So do you see you're going across an extra 2 to go from 11 to 13? Well, it's the same situation here then. So with 19, we're going to go across an extra 2 to get to the value we need to here. So we're actually going across from the origin 21, okay? Because that's what you get when you add 2 onto 19. So we get to 21, and then we're going to go up 9. So 21, 9. Okay, now I would write that in there, because then it'll help you when it comes to working out C. And for C, again, to get to C, you've got to go across the same amount, haven't you? So you've got to go across 21. Okay. The question is then how many you go up. Okay. How many you go up there. And if you think about it, I mean, just looking at it, even though it's not drawn to scale, you're going sort of down to -1 here. So you'd imagine then you're going up to +1 here. You'd imagine that would be the case. But it does say not drawn to scale, so we need to be careful on that there. And another way of checking is appreciating that the length of the parallelogram here is, well, from -1 to 7, that length is going to be 8, isn't it? If you go from -1 to 7, and the same is going to be true to the other side, because it's a parallelogram. Opposite sides are parallel, so equal in length as well. And that distance there is going to be 8. So if we're 9 there, if we take away 8, we end up being, take away 8 from 9, we end up being 1. So yeah, the coordinate for C is 21, 1.